We're up to the fourth of our 5 lessons in this module for weeks 3 and 4, and the title of this lecture is Mutable and Immutable Types. Now, this is not likely to be terminology that you've heard before in other programming languages, but the concept is very important in Python. Now, we've spent time talking about lists and strings, and we're going to see how one of them is mutable and one is immutable, and what that means to us when we write our programs. So let's get started. Now, as we learned in 3a and 3b, lists and strings have a lot of things in common. You can find the length, which is the number of elements in a list or a string, by using the built-in function len. You just do len parenthesis and the name of your variable, or a constant like quote string value end quote. You can specify particular values using slicing. We did slices with square brackets and either a single number or 2 numbers separated by colons or 3 numbers separated by colons for a start, a stop, and a step value. And we could use that with both lists and strings. We can iterate on both lists and strings. We did that in for loops for a particular element in a list or a string variable, and it would loop through our code once for each element in the collection, whether that collection was a list or a string. Very convenient to use in a program. But there's something that we can do with lists that we can't do with strings. Let's take a look at that as we go to the next page. What they don't have in common: you can change specific elements of a list, but you can't change specific elements of a string. You can replace an entire string, but you can't change just the second character or only positions 5 through 8. So here's some examples of things that you can do with a list but not a string. Let's say we had a variable called mylist that had values 0, 1, 2, and 3. So it's a 4-element collection. And then we say, let's make mylist square bracket 1 equal to 17. That changes whatever the element is in position 1. Remember, we start with position 0. Here's position 0, here's position 1. We replace that with a 17, so now the value of the list looks like this: 0, 17, 2, and 3. But if we try and do something similar to that with a string, my string equals quote ABCD. If we did the length of this string, it would have 4 elements in it. If we tried to print out just my string square bracket 1, it would print out the letter B. I can refer to slices, but if I try and put the slice on the left side of an equal sign and use it for assignment, if I say, let's change my string square bracket 1 to the letter X, it will cause Python not only not to do it, but your program will stop with an execution error. You cannot change individual elements within a string. All you can do is reassign the entire variable. You could say my string equals quote AXCD, but that just replaces one string with another. It doesn't change the string once it's created. This is an example of what's called in Python a mutation, or the property of mutability. Changing specific elements within a sequence is called mutating that sequence. Lists are mutable, strings are immutable. You can reassign a complete new sequence, but you can't change an existing sequence. So my string equals ABCD, perfectly legal to say my string equals XYZ afterwards. I can't go my string square bracket 0, 1 equals quote DC. I can do something like that with lists, not strings. Now, you might ask, why does Python make a distinction between mutable and immutable objects? And there's an awful lot of discussion about it. You might want to, just for fun, sometime go into Google and say, why does Python have mutable and immutable objects? And you'll hear a lot of things about how immutable objects protect programmers from themselves. Immutable objects are slightly more efficient than mutable objects, and so on. But I think mostly the reason is because. because the people who created Python put them in there, and now people are used to it. Now, we saw that lists were mutable. There's a version of a list that's called a tuple, T-U-P-L-E, like quintuple, sextuple, octuple, and so on, that acts in every way exactly like a list, except that it's immutable. We specify lists with square brackets, so if I have a variable called L that equals square bracket 0, 1, 2, 3, 4, 5, it's got 6 elements in it. If I have a different variable called T for tuple, if I specify it with parentheses instead of with square brackets, it works just like a list. I can iterate over it, I can slice it, I can pass it to any function that was taking a list, would take a tuple instead. However, it's immutable. I can refer to T 1:4 and it gives me everything from position 1 up to but not including position 4, but I can't put that on the left side of an equal sign and assign a new value. I can't change the contents of the tuple by doing t.append like I could with the list. I could do l.append 17 and the list would get one element bigger with the value of the last element being a 17. Can't happen with a tuple. You might also want to Google why does Python have tuples, and you'll see a lot of argument on both sides of the equation. We aren't going to use them an awful lot, but they do show up when we implement packages that have been written by other people. They often have tuples in them, so we need to recognize them. Now, what's the danger of iterating on a mutable object? Iterating on a list is very helpful to us. We've seen that in putting together for loops that go through every element in a list one at a time, which is usually what we want to do. But since Python lets me change a list, what happens if I change the list while I'm iterating on it? This is the source of an awful lot of real pesky errors by novice Python programmers, and sometimes it leads to errors that you don't detect. The program doesn't blow up, you just don't get the answers you should. And sometimes it will cause a program to have an execution error, and sometimes it will cause a program to execute forever without ever stopping. So, how could this happen? Suppose you wanted to duplicate all the elements of a list by appending them one at a time. So you had my list, and it consisted of these 5 numbers, 4, -8, 10, and so on. And you wanted to go through a loop that said, for x in my list, let's take my list and append the value of x. So the first time through the loop, I'll take that 4 that's in that first position and append it to the end. The second time through, I'll take -8, append it to the end. What's wrong with this? Well, if I'm going through x in my list, and my list is getting bigger each time, I am never going to finish this loop. I'll put a 4 at the end, then a -8, then a 10, then a 3, then a 19. Then I will get to that first 4 that I added in, and this will run forever. It will not stop. Your list will get bigger and bigger until eventually you use all the memory in the entire machine, and then your program will crash. Not what you intended. So don't do this. Do not change the value of a mutable object that you're iterating over in the loop in which you're doing the iteration. So, what's a way around the problem? You could iterate over a copy of the list instead of over the list itself. So my list is the mutable list that has those 5 elements in it. If I go for x in list parenthesis my list, that makes a new copy of my list at the time you start the loop. And that new copy, which has 5 elements in it and will never get more, is what you're iterating over. Then you can go mylist.append x, and my list will get bigger. It'll add a 4 at the end, a -8, a 10, a 3, and a 19. But this copy of the list that you're iterating over didn't get those things added to it, so your loop will end as you wanted after 5 iterations. Instead of saying list my list, you could just say for x in my list and give it a slice that goes from the beginning to the end, because you're leaving out the values in the slice notation. So it's going to give you everything in the list. It makes a copy. That slice is a copy of those 5 elements, and you can go through your loop that way. Of course, you could do this without a loop if you just remembered some of those list functions we did in Lesson 3a. If you do mylist.extend instead of append, it says take all the elements in my list and stick them on the end of the existing list. And that would work just as well. Okay, you might want to go into idle and do some playing around with lists and strings and prove what's iterable, what's mutable, what's not mutable. Create some infinite loops, and then remember to hit Control-C to get out of them before you die of old age waiting for them to finish. And then come back when you're ready to look at our last lesson of this unit, which is 3e. It'll give us some information about how to get some useful statistical information out of data that you'll be putting into use in our programs for this week. Happy programming.